Welcome to my channel. My name is Kidana Maran. In the previous tutorial, that is tutorial part 2, we have seen that how to draw column, how to draw beams, how to draw slab, how to draw shear wall. Today I will show you how to assign pier and spandrel on wall, how to assign diaphragm on slab, how to mesh slab. After completing watching this video, you have to master ETABS 2016 and structural design of projects. Don't forget subscribe and share this channel to get more related video. Okay, it's better to start. I have missed that showing you how to draw staircase. I will show it for 5 minutes now before proceeding to that tutorial. So to draw your staircase, you have to first draw your reference plane. So to draw your reference plane, you have to go to draw menu. Okay, you have to use other choice. Right click here, modify grid lines. So click on modify grid. Okay, this is a reference plane, so make it click on. So a reference plane is coming. So to do this, first it's better to look your architectural plan, section view of your architectural plan. So first I want to show that I have to start from ground floor and draw staircase to first floor, that is pass to first floor, and replicate it to other floor. So from first floor, have to draw a reference plane at landing point. So it is up to 1.6 meter, and to the second floor, to the first floor, it's 1.6, and to the next landing or to the next reference plane, it's up to 3.2. So first you have to put 1.6 meter and add 3.2 for each floors to reach up to roof terrace. So I will do this on ETABS. Make it add 1.6, that is the first reference plane or the first landing position. Make it add 1.6 plus 3.2, the second reference plane or the second landing point, and make it 4.8 plus 3.2 to the next landing point, 4.6 plus 3.2. Okay, and 3.8 plus 3.2. That's good. Make it at 11 plus 3.2. Make it at what is that? 14 plus 14.2 meter plus 3.2. Okay, make it okay. Okay, so go to plan. Oh no, go to elevation. Take one elevation to show your reference plane. Yes, your reference plane is this. So from up to terrace floor, that is the position of landing beam. So go to plan and draw your staircase. Draw your staircase. Ground floor. Okay, make it delete this beam first, and you can draw it again. Okay. Draw beam. Starting from this to this, And look, it's better to look your architectural plan. So our beam is on this. So I will draw a line from this to this. So I have a slab here, a landing slab. That is 1.88 meter from your center or from axis C. 1.88 meter. So you have to replicate this beam. 1.88 meter to the positive x direction, and draw your slab. Okay, make it delete. So have to draw your beam. Change your material. So have to divide it. Okay, first it's better to measure this up to the dimension from this to this. So draw dimension line. This up to this is 2.67. 2.67. So divided this frame into two. Go to click on it, go to edit frame, divided frame, divided into two, make it okay. Our frame is divided into equal parts. So I will check architectural plan. Okay, the first stair slab, that's the width slab, is starting from this land here and back to this. So have to click on it, go to edit menu, extrude frame to shell. Okay, at this time have to put 2.67 meter. That is, I have measured before from this to this 2.67 meter to the positive x direction, and make it 0 to y direction, and 1.6 meter to the z direction or elevation. That is shown on section view. 1.6 meter from ground floor. You have to get your landing or your reference plane. So make it one times, apply. Okay, that's good. Make it in 3D. So your staircase is drawn here. Our staircase is drawn like this. Check the material of staircase. Okay, I will zoom it, make it, click on it. Okay, it is a stair 1.6. That is good. So have to draw your landing beam. That is what a landing slab. Okay, this part. To draw this, have to go to plan view. Go to plan view, measure this dimension from this to this. That is 1.51. 1.51. So make it ready. Draw a line from this to this. Click on it and go to edit, extrude frame to shell. So 1.51 to the positive x direction and make it 0, the elevation, because at this point we are at the landing level or the reference plane level. So make it okay. Our slab is drawn like this. So to draw it fully, go to draw. Okay. So the slab is drawn to draw it beam. Make it delete. Go to plan view. So you have to measure the dimension from this to this. Go to draw lines. This up to this. That is 2.8 meters. So make it ready. Select this beam that have to draw for a reference. So edit, extrude frame to shell. Make it 0 because you have to draw to the y direction. So 2.8 to the positive y direction and make it 0 elevation because we are at landing position. So make it okay. Our slab is drawn like this. So have to delete this and this line because their function is for a reference. So make it delete and draw the reference from this point to this. So click on it and you have to draw your next step. So edit, extrude frame to shell. Make it minus 2.67, 1.6. Your staircase is automatically drawn. After this, you have to replicate this to other floor. Replicate story to basement. Okay. To ground. To ground. Okay. That is good. Make it plan. So there is unwanted beam here, drawn here. Make it plan. Second. So this beam, a reference beam. Like this. So make it 3D. Plan. It's better to replicate first floor to others. So make it ready first, and you have to delete. Okay, that's good. So make it first floor and replicate to the other to save time rather than drawing. So to draw to second, third, fourth, fifth terrace, and make it to water tanker, and you have to edit it. So make it ready. Show your staircase. Okay, your stair is not replicated to other floor, so it's up to ground, second, first. So have to replicate to other floor. Simply to do this, go to replicate, third, fourth, fifth stairs. Okay. So might go to plan water tanker. So our water tanker is looks like this. So I have to draw, have to delete all this and this. To water tanker. So and make it a reference plane here. Click on here, edit. So have to draw slab for water tanker is 150. This is, so change this material slab 150, and you have to delete this, delete all this. First, it's better to make a reference plane here. So you have to delete all this and draw it again. Draw it again. So have to draw first your beam. That is 14 by 20. Make it join frame. Okay. So you have to change this beam, or you can change the section. Show section beam. So it is 40 by 25. Change it. That is select, assign, frame section 40 by 20. Okay. It's better to draw beam here. Click on it. So join these two beam to act as a one beam. Okay. So have to draw your slab. This up to this. This is a short length, so it becomes as it is. So make it save. Okay, you have to draw your landing beam. To draw your landing beam, make it plan. So you can start from reference plane 1. Your landing beam is here in this. So select beam, make it yes. So okay, click on here to here. For choose all the reference planes, it's better to draw your landing beam. Your reference plane is drawn to at the same level of your landing beam. So draw all the landing beams at the reference plane. And you can assign all the load. I will show this in the next tutorial, that is tutorial part 4. It's okay, go to elevation, show axis D. Okay, all your landing beams are drawn like this. After this, it's better to go to assign pier and spandrel to wall. To assign pier and spandrel, you have to go to a shear wall. So to do this, go to plan, ground. It's better to draw a developed elevation for this one. To do this, you have to go to draw. I will tell you later the advantage of drawing developed elevation. Make it okay. So draw okay. Now draw developed elevation. Elevation 2. Okay. Starting from this to this and this, this. Okay. So developed elevation of the shear wall is coming like this. So have to define first what is spandrel mean and what is pier mean. Spandrel is a horizontal member of shear wall act as a beam. Spandrel is a wall that is above the opening and put around this. So to do this, first I have to draw all the spandrels, and a pier is a vertical element act as a column. A vertical element act as a column, and it starts from the base and passes to or extends to the top. So this is all the pier, and the spandrel is around this above the opening. So I have to draw all the spandrels, and then we have to align it. Okay. So to do or to draw the spandrel, click on it, click at the basement floor, and have to go to draw joint object, joint object, offset 2 point. Okay, I will show this in structural plan of my drawing. Go to Okay. This is a spandrel have to draw above the opening. All these are the spandrels, and all these are a pier. So have to going to draw this spandrel. So have to measure the dimension of the opening. That is 200. That is 200 centimeter, and the rest part is part of the spandrel. So 200 centimeter, and click on it. Okay, automatically have a get my point and click on this also. Okay, so go to slab, draw the opening, starting from this, 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 and this. That is good. And to draw the spandrel, go to, you have to draw a shear wall into two ways, on the slab command and on the wall command, and further it has considered as a shear wall if you assign as spandrel and assign as pier respectively. Without assigning, the slab only considers this wall as a vertical slab. So you can draw using your shear wall using slab command. Wall 220. So this. Okay, have draw a spandrel, and it's better to replicate to other floor, both the opening and the spandrels to other floor. Make it replicate story to the first, second, third, fourth, terrace. Okay, yeah, it's good. Okay, after this we are going to assign pier and spandrel. So to assign, before assign, have to define your parent spandrel. To do this, you have to go to plan, to go to plan. Okay, it is good to draw your shear wall around the territory of your building first. So make it draw a wall by simply clicking on points. Have to draw your wall. This is area of ramp, two basements. So check your architectural plan to draw exactly the location of your shear wall. So I have assigned all the pair by counting for this wall 1 pair, for this wall 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 30, 40, and 50, 16, 70, 80, 90. 90 pairs. So 19 pairs. So go to define pair label, pair 2, add pair 3, add. Okay. You can give one name of pair rather than differentiating the name of pair. You have to differentiate, or you have to define different level of pair if the section is different. So it's better to define all this by one name. So pair 1, make it ready. Go to select by property, that is wall section, wall 200 20. Make it okay. Make it right click here, hide select object, show select object only. So you have to click all to the wall, all to the wall, and assign your pair. Okay, select all the wall. Excluding the spandrel, you can select all the walls to assign as a pair. Okay, assign shell pair label as P1. Make it okay. Okay, this are not selected. Shell pair label. Okay, go to elevation 2, and you have to assign all your spandrels. Before assigning the spandrel, you have to define your spandrel. Go to define spandrel label, make it S1. So selecting this, all the spandrels that is above the opening, a wall above the opening is called a spandrel. So assign shell spandrel label S1. This is all about assigning pier and spandrel to well. And second to this, I have to show what is meshing. Make it ready. Okay, make it right click on here. show all objects. So I have to proceed to meshing. Why we are going to mesh the slab? We have to mesh slab and shear wall to define a number of equations that ETABS will be calculate during analysis. I will show this on AutoCAD by taking some example. For example, if you have to take this slab that is 4.55 by 3.85, 4.55 by 3.85. So if you have to take this slab, it's better to divide it into different elements. If we have to take one element that is 1 meter by 1 meter, 1 meter to this direction, and 1 meter to this direction. So if you have to, this is whole slab, and I have take one element that is 1 meter by 1 meter. This slab has 8 nodes. This element have 8 nodes. That is, at this point, this slab has 8 nodes. That is, I will show it one by one. If you have to take this point, this point, this point, this. Okay. This 1 meter by 1 meter element from the slab has 8 nodes. 8 nodes with 6 degrees of freedom. 8 node with 6 degrees of freedom. So if you have to multiply this 8 node by 6 degrees of freedom, that is 3 rotation in XYZ and 3 translation in XYZ, you have to get 48. That is 6 by 8, 48. That is 48 number of equations that it has used for analysis. This is the reason that we have to going to mesh the slab to increase number of equation and to get every point or every load or every movement and shear at every point of your building or your panel, as I shown from here. So to do this, you have to go to analyze. Well, we have two types of meshing, that is automatic and by meshing it by yourself or by the user. To mesh slab, you have to use this setting. So approximately maximum size. Okay, use meshing, that is better to use 1 meter by 1 meter. Make it okay. And select all your walls. So go to select. Okay, sorry. First you have to select all your wall. Go to select by property, that is wall section. Select wall 200 centimeter. Okay, so you have to go to assign shell. Okay, you have a wall automation option and floor automation option. For meshing your slab, you have to use floor automation floor automation option, and to your wall, you have to use wall automation option. We have two choices for automation of slab. Okay, one choice is here, and the other I will show the other choice later. So have to use wall automation option to mesh your wall. This time you can automate it by yourself or by user by changing this number, and it's better to use automation, rectangular automation. That is, it has automatically mesh it by using the default setting. Make it okay. At this time, automatically it has automation. This it says auto to show the meshing size. Have to go to this and show shell automation option. Make it okay. It takes some time. So yes, automatically wall automation is coming. Wall automation is coming. You have to go to analyze and check the second choice, automatic mesh setting for floor. So 1 meter by 1 meter, you have to change this number by 0.5 by 0.5. But number of equation is added, and it has take more time to calculate the iteration. So make it 1. Okay. So meshing is finished here, and it's better to go to diaphragm, assigning of diaphragm. First, I have to define what is diaphragm mean, and what is the advantage of assigning diaphragm. Okay, we have to assign diaphragm on slab. Two late beams, columns, and shear walls act monolithically, or in the integrated manner. To access your building in an integrated manner. And there is other advantages of assigning diaphragm, that is to connect each node or joint that I have shown on meshing option, and to transfer lateral loads to beam and column from slab. And the other advantage of diaphragm is that to generate center of mass, to calculate center of rigidity. So to assign diaphragm on your slab for n number of story, that is you have to assign n number of diaphragm, or you can use one diaphragm for each story. We have two types of diaphragm on ETABS. So to assign diaphragm, first you have to select all your slabs. So go to select menu, select by property slab. So you have to choose all your slab. Assigning diaphragm on stair landing is not necessary, because it has automatically shows a message that is a warning message when you check your model. So it's not better to assign diaphragm on your stair landing. So you have to select only slab of 150 mm and slab of 160 centimeter. I mean, it's in centimeter. So make it select and close. So go to assign shell diaphragm D1. Before this, I have to go to. Before this, I have to define my diaphragm first. So as I define diaphragm, first I have to go to assign diaphragm. So make it modify. Okay, we have two types of diaphragm, that is rigid diaphragm and semi-rigid diaphragm. Rigid diaphragm means that points at floor level displaced laterally at equal magnitude, or relative lateral displacement is 0. So it does not need iteration and requires short analysis period. There is no lateral displacement. All the building acts monolithically. But semi-rigid diaphragm means that there is a relative displacement. To decrease it, 0, ETABS needs iteration and analysis takes a long period of time. So uh, there is some lateral displacement of this. To reduce iteration and to reduce your lateral displacement, you have to, it's better to use a rigid one. So make it okay. Okay. As I have defined the diaphragm, it's better to attain the diaphragm on slab. So you have to select slab. Okay, by property, that is slab property. So select, make it okay. Go to assign, shell, diaphragm, U1. That I have changed all the property, make it okay. Yes. The diaphragm and the center of mass of the building is up here. I will show this by selecting one plan. That is, yes, this is the center of mass, the center of mass of our building that used to calculate center of rigidity, center of mass of the building. So diaphragm is defined like this, and there is a full load transfer from slab to beam and to the column if you have to define your diaphragm. It is enough for today. So in the next tutorial, that is tutorial part 4, I will show you how to define and combine loads, including wind load, imperfection load, soil pressure load, for both static and modal, or that of response spectrum analysis method. Thank you. Don't forget subscribe my channel to get more videos.